Okay, welcome. Hi, this is Henning. I'm going to give a talk today about Anchored in Innovation, the story of Kusto. Before I would start, I would like to say thank you so much to the sponsors, and also thank you so much for inviting me. Thank you for having me. I'm incredibly honored to be here, and it's going to be great fun. Okay, so first quickly, who am I? I'm a Microsoft employee. I'm a product manager in the Kusto team. So we are the ones who are building that. And in our team, I drive features around security. So everything around network security, identity authentication, that stuff. Or geo features, BCDR story, so business continuity and disaster recovery, and also graph. Actually, I consider myself this being something like a side gig, a PM job. Actually, I'm Professor Smoke, and I help as a contractor in the Kusto Detective Agency. For those who don't know Kusto Detective Agency, I think there's going to be a couple of mentionings here. If you want to reach out to me, feel free to reach out on X or on LinkedIn or any other channel that you know of. I think it's easy to find me. I think I was invited to the session to talk a bit about what is Kusto and what is the history of Kusto? So my idea was to start with something that I called the Kusto story. So the story of Kusto. So we go through the timeline from its birth to its current developments. I'm going to talk about a little bit about roadmap. Of course, I can't disclose too much. And what's going to happen with the Kusto Detective Agency. And of course, feel free to ask questions in the chat. We are answering them as fast as possible. And let's have a little bit of fun. Trying to do a lot of demos, so may the demo gods be with me. So what is Kusto? Kusto, that's usually something that I bring in when I'm in customer conversation. Kusto is a big data analytics cloud platform optimized for interactive and ad hoc queries. What does that mean? It's big data is a stream of timestamped activity records of measurements that comes with high volume, high velocity, structured, semi-structured, or free text data. It's built for analytics. It comes with classic relational query engine, so it supports filters, selection, projections, joins, calculated columns. A lot of the stuff you have already been seen in Gianni's and Alex sessions. And nowadays it also comes with graph, and I believe I'm going to talk a bit about it, but also other speakers in this conference are going to talk about it. We're incredibly proud. It's a cloud offering, which is fully managed, and it comes as a platform. As a vanilla platform, you can do like a lot of things with it. In this conference, most of the stuff is around security, log analytics, and Sentinel, so stuff that runs on top of Kusto. But there are also a lot of other things, and I'm trying to bring you, as part of my talk, also perspective on other things that you can do with it. But it's not only a PaaS database any longer. We also switched gears in our latest Fabric developments and made it available as a SaaS offering for customers. It was purposely built for that exact job of being able to deal with a lot of data. We made a couple of trade-offs in building the engines, but it was purposely built for what we are doing. And it was also built for interactive workloads. So we don't want to wait like 5 hours until we get an answer. We would like to have immediate answers, and we purposely built the platform for that requirement. Let's talk about the family, okay? Let's talk about the family to give you some perspective where the Kusto is, where the tech stack is, and what are the products that we are building. So my team, our team, we are building the technology stack, which is Kusto. It's at the bottom. It's the name of the engine, the name that we have chosen. It's named after or inspired by the name of Jacques Kusto, a famous deep sea diver and researcher. Just a little bit simplified and not with the French touch. On top of that, we're building products. This is also part of my team. We are building something that is called Event House in Fabric Real-Time Intelligence. So Fabric, it's Microsoft's latest SaaS offering for analytics. And we are building that and build Kusto as a SaaS offering on that platform, which is very cool. But there's also the existing offering on Azure. It's called Azure Data Explorer. Oftentimes in this conference, you hear it as ADX. and that's used for a lot of scenarios by tens of thousands of customers. But there's also something that I would like to demonstrate also today. It's, and as you see, we are very creative with names, is Kustainer. Guess what it is? It's Kusto in a container, which is useful in a ton of scenarios, for example, disconnected CI/CD scenarios, and I can think of a lot of other things. On top of that, we built solutions, and solutions have been built by our friends in the Azure Monitor team, but also Sentinel and Defender. All of them, they are built on top of the technology stack that we are providing to them. And also other things like PlayFab, so game studios are using this technology to store statistics and telemetry of games. So far to the family, whenever I talk about Kusto, and probably this is the first time in the forum that probably most of the attendees know Kusto, still it's kind of Microsoft best kept secret. And I want to change that every day. But those numbers, I still need to bring them up, and that it also shows like the size of that platform, right? So on a daily basis, people system ingest into that platform roughly 300 petabytes of data. Just let that sink in for a moment. 300 petabytes of data, and on a daily basis, on a monthly basis, the total ingested volume is roughly 8.3 exabyte. And we're talking here about the compressed volume, so the actual uncompressed is way higher. There are roughly more than 4 billion queries which are executed every day, and we are consuming approximately 5 to 6 million cores on Azure. Depending on how you count, this is the more like pessimistic count, there are roughly 500,000 KQL developers out there, so you are amongst friends, a lot of many friends, and so the size of the platform is just huge. So investing into it for your own career, for example, makes a lot of sense. Now let's start with the Kusto story. So that picture has been taken by our general manager, our VP, Odette, and on the left you see Avner, on the right you see Alex Efron. They're doing like deep sea diving, and you see the Kusto flag, our first logo. So let's talk about what actually happened. And I'm going to present you the timeline. And after I finished one of these slides, I'm going to show you examples of all of the items that you find on this timeline. So we celebrate our birthday on 8th of March. And the first commit hit our source control management system on 8th of March 2014. So we are pretty young, 10 years. We just celebrated our 10th birthday this year, but right from the beginning we had KQL, so the Kusto query language. We made the decision to come up with a new language that is more appropriate for all workloads, and it's easier for users out there, as you have seen. Also, right from the beginning, we started being a scale-out database. So we didn't stop at a single node. We started being a database that can scale out to hundreds or up to 1,000 nodes, essentially, under the hood. We also built time series operators. We introduced the dynamic as a data type. Gianni was already talking about, so that you can use the dynamic property to store JSON information, arrays, complex objects, very useful. If you want to combine certain data sets, you can leverage joins with all different join flavors. That's a classic of a relational algebra. And also the in operator, very important. We released our second version of the engine v2, and just I think 2 years ago, we retired it, and with engine v3 now being in place. Right from the beginning, our aspiration was to work at Microsoft scale. Microsoft scale, I'm going to demo it later, is huge. And our goal was always to provide to our customers the capability to work at Microsoft scale. We started with first production customers and partnered with internal teams. So let's have a look at some demos, right? So the demo environment that you see here is Fabric, and I'm using Fabric query sets, but you could also use a Kusto Explorer or Kusto Web Explorer or anything else. It doesn't really matter. What we're looking at here is is a scenario where a customer is sending a lot of logs to Azure Data Explorer, and we are analyzing those logs. And we're looking here at a specific database, which is called SQL BI. So we're looking at an old data set from a neighboring PG. And we just take a look like how much data we are actually ingesting and how much actually is being stored. The query is running. A second, it's a lot of data. So what we see here is that the original size that was ingested into this database, into this specific table, was 8 terabyte. We stored 310 terabyte, which means that whenever we get data from our customers, under the hood, we are storing it in a compressed columnar model, which sometimes leads to 7, maybe 10, sometimes even higher compression rate. And what's very important for us is that customers only pay for what they're actually using. You see it also here, this table has 22 terabyte in the original size. So that was the amount of the volume that was ingested, and we stored 2 terabyte. Let's have a look at some data and some simple queries. We're looking here at some Azure traces, and it's roughly 40 billion, maybe 41 billion rows. And all of those are live queries. So I'm not going and take a look at some pre-calculated data sets. Here I'm looking at traces in a specific time range, and then I'm counting them by error level because you probably want to understand what your application is doing. And there are some which look suspicious, so I'm now looking for the errors. So for these, so I'm looking for a specific level. You see here, this is the KQL, the Kusto query language. So the output of line number 25 is the input of line number 26, and so on and so forth. So it's very easy to read from top to bottom. And then just take a look at what we're actually seeing here. See a couple of columns, and then in the event text you find some strings. Sometimes you find stack traces, all kinds of things. Now I would like to get the distribution by role, and what role means is I have some role column over here. It's a string that starts with a BER role and then some number with an underscore. I can just use the parse function to parse role and extract the role type, and then I can do a render by role type. I'm rendering now a time chart very easily, and that's what our customers actually love. They are able to immediately connect with their data, to see the data as it streams in high velocity. So let's look and do some further research. The let statement is something that Gianni already talked about. It allows us to define something. Here we're defining that we want to look at specific traces in a specific time period where the client ID is not this static one. And then we take the lookup input, search for specific events. We're extracting users, and then we join it again with the lookup input with the error levels. And what we get is the distribution here. I see this user ID has the most errors, so it's probably the most frustrated users. And just keep in mind, like 41 billion records that we are working on here live without any further caching. So let's take a look at that specific user and what's actually happening here. And we find out, ooh, the database does not exist. So I get a nice bar chart. So probably it's an application which was using an old configuration, and we find out that it's not working correctly. And then we can dive into those kinds of things even more, find certain specific jump shapes, but let's not spend too much time on that. So that's the, let's say, large-scale logs portion of what I wanted to show to you. This query is something that we're not showing too often. So this is hitting a system which is called Couscous. Couscous is the Kusto cluster of all Kusto clusters. And so here we have the information of how much data is being ingested. So what's the total amount of bytes which is being ingested, how much it has been compressed. And what this query is essentially doing is looking at the last 5 days, and it's calculating the top cluster and how much it was ingesting. So we see here that in the last 5 days, on any given, like on one of these days, and cluster that I don't want to disclose, ingested 5 petabyte per day, 5 petabyte and it compressed to 400 terabyte, which is quite significant. So the customer here decided to put 5 petabyte into the database, but it's only paying for 400 terabyte, which is kind of great. Now, if you, as me, are using this database for your home automation, and you're probably going to see a lot of my home automation in this talk, you will deal with time series and time series queries pretty fast, because you want to find out, hey, is this actually this temperature that I'm seeing, is it an anomaly? What about the wind speed? Is that an anomaly? And you can do that very, very easy with Kusto. So you're looking here at live data from my home automation, okay? And we're looking here at a specific data set. Let me just show you how it looks like, and to explain you also the difference from a time series to regular operators. So you get here a couple of rows. Most important thing is you have a value, you have a couple of timestamps, you have a data point type, and all of our time series operations, they're not working on rows, they're working on vectors. So the make series operator gives us those kinds of vectors. So you use the make series operator, and then you group by device name and data point. Here just specified one device and one data point, and it gives you 2 vectors for each of those combinations, one with the timestamps and the other one with the actual values. And then what you can do here is, that's very important for a lot of time series operation. You can fill the data if it's not complete. In this case, it is complete, and then you can simply extend anomalies and render an anomaly chart. So very easily you can spot, okay, so in the wind speed in the last couple of days, there were definitely some anomalies where it was like more windy than during other times. And you can use those kinds of queries for a lot of scenarios. And as easy as that, you see it's almost the exact same query. I can also do a forecasting. So now I'm forecasting, I believe, the temperature in the room of my daughter. And you see the orange one, it's the forecast, and the blue one is just a continuous line. So it stops here, and then there are no new values, but the orange one is actually the forecast. You see it's getting maybe a little bit colder. I don't know why. Maybe she is working on the set point. But you see it's getting a little bit colder, and it's pretty much like nicely aligned. All of that comes out of the box with KQL. Cool. So let me switch back to the presentation. We talked about joins, dynamics, KQL in general, and how we're doing when it comes to ingestion at Microsoft scale. Let's take a look at the next part of the timeline. So in April 2017, like a very important milestone happened for us. Internally at Microsoft, we became something like a de facto standard for logs and telemetry. Right now at Microsoft, roughly 99.9% of all log and telemetry goes into the Kusto platform. So our first customers were Azure, entire Azure, Office, and Windows. And now we're talking about entire Microsoft. In 2018, though, Scott Guthrie was talking in public about an announcement to make Kusto available as a service to our third-party customers. So not only internal first-party, but also external third-party customers. And like shortly after that, we made an amazing decision. So we open sourced our query language. KQL is actually available as under an MIT license on GitHub. And we invested heavily in creating SDKs in all kinds of languages. Let me just show you that really quickly. It's going to be a short one. So this language, you can go here just to Microsoft Kusto query language. It's available under MIT. It's used by a lot of, meanwhile, open source databases, as well as IA and Inspiration for creating their own query language, or B, as a direct copy, which is great. So we have other database vendors which are adopting this language because it makes a ton of sense to have it. So have a look and check out the query language. If it's interesting for your project, just fork it, work with it, contribute back. We're open. Now, you can talk to Kusto, to any Kusto, and here we're not only talking about, for example, Azure Data Explorer. You can talk to any Kusto in like various APIs. Of course, everything is based under the hood on a REST API. And we have .NET, Java, Go, Python, R, PowerShell, Node, and probably also a couple of others which I forgot. But you can talk with Kusto with pretty much like every query language, every programming language that you like. Okay, so let's go back to the timeline. In 2019, that's approximately the time when I joined the product team. We made that service called Azure Data Explorer generally available for all customers. So this means as a third-party customer, company ABZ, I can go to the Azure portal and say, hey, I would like to have this beautiful service, and then send all of my logs to it. This is the point where it happened. We quickly realized that for large customers and enterprises, we need to have enterprise features. Those kinds of enterprise features are, for example, something that we already deprecated now in favor of other features, virtual network injection, private endpoints at some point. We needed to have a strategy around business continuity, disaster recovery, and all of these enterprise features which are required for having a good and reliable service. We added a lot of powerful engine features. One of the ones that I remember is definitely our geospatial operators that we added. We strengthened our ecosystem, and ecosystem here starts with, of course, partners. We developed a partner ecosystem. We also strengthened our ecosystem in the open source community by writing plugins for Logstash, Telegraph, FluentD, FluentBit. I'm going to show you the ones later on. And then at some point, we also did, in my opinion, an amazing decision by introducing something that's called free clusters. Not everybody, including me, has the budget to work with a full-blown Azure Data Explorer cluster 24/7. And I would like to still be able to play with it, to use the technology. And for that, we introduced those free clusters, which essentially mean from Microsoft, you get a cluster, an Azure Data Explorer cluster, which has the capability of 2 cores, and up to 100 gigabyte of data that you can store, and you get the entire capability of the engine without hosting it yourself. I'm using it on a daily basis with ingesting my data from Home Assistant or from my home environment into this database and just track how it's going. Back also in these days, we introduced the Kusto Web Explorer and also the dashboard capabilities, additional capabilities to ingest data using a get data experience or a UX which guides users through the process. And then in 2022, that's the next big milestone, we were added to Azure Synapse as something that's called Kusto Pools. For us, and also for the entire industry, this was a move in the absolutely right direction, because we were recognized as one of the major engines at Microsoft. So before us joining Synapse, there were only Spark and SQL. And we were introduced as the third main engine to this family for operational analytics. So for us, this is a very important milestone, being recognized as the third engine of Microsoft. Now, shortly after that, we realized let's do something different when it comes to training. Okay, so because we already have like a lot of learn resources, we have specific courses that we are offering, but let's do something different. And here we decided to actually create a game, and that game is called the Kusto Detective Agency. It started with the first season, and in the first season, like every week, we released a new task. So you started in the Kusto Detective Agency as a rookie, somebody with like a low grade, And then you start and implementing specific use cases, play with the data, and you solve specific cases, which is great because you learn on a really concrete scenario how to solve certain problems. So you were able to play with geospatial operators. You were able to play also with the graph operators. At some point in the second season, we even decided to release the graph operators as part of the Kusto Detective Agency. And I think we are the first team who released the feature as part of a game. That was also the time when we released the Engine v3, which was completely rewritten on Rust. And we are now working only on Engine v3. We also released Kustainer, or it's also called Kusto Emulator, and improved our docs and documentation dramatically. Let me just show you a couple of these items. Let's start with Docker, right? I received the question before the conference, and let me just show you what we're doing here. Is the so-called Kustainer or Kusto Emulator is available on a Docker registry. Just search for it, and you will find it, and you can just run it. Here I'm running it. It's called very funny Suspicious Beaver. And if I take a look at, for example, my PowerShell and do a Docker PS, I see that it's running since yesterday evening when I decided to show Kustainer. And you can run it. It's running on my local laptop here. You can ingest data. For example, I could now also ingest, let's do something like an inline ingest. Let's say Ellery 42. It's ingesting now, and then I can run a KQL query, which is summarizing stuff. So you have the entire engine here. One thing to note, it's not for production use. It's mostly been built for disconnected CI/CD scenarios, but if you're interested, just talk to me and reach out to me. So that's Kustainer, so Kusto container running here on my notebook, okay? Okay, so let's have a look at other things that we developed. Let's have a look at some of the engine features which we built. And let's start with the geospatial stuff, which I'm also very proud of. So we started working with a lot of big customers. And those big customers, they had tons of geospatial data. And they tried to plot them. But plotting like millions and millions of events on a map is not simple. So we started to develop clustering algorithms, geospatial clustering algorithms. We started with geohashes as 2 cells and then H3. And what you can do with it is, for example, you can have a static table of polygons like the US states. You calculate the covering of US states with polygons and as 2 cells, and then you join it with actual events. In this case, it's storm events. And here, let me just execute it real quick. You see, for example, Texas has a couple of storm events, Kansas, Iowa, Nebraska, and we did that using geospatial clustering. One more thing that we created along those, which is also something that's totally new, is we created a state machine directly in Kusto, and the state machine was implemented using the scan operator. Right, so we again go back to the storm events. Let's just have a look at the table. This table is also available on our help cluster. You see start time, end time, and then there was heavy rain, a couple of injuries, begin location, end location. That's the data how it looks like. Now what we are doing here is we're introducing partitioning, and we're partitioning the query by state. So everything that you see in the brackets is executed, and the parentheses is executed by state. And then within a state, we sort by start timestamp, and then we use the scan operator to define a state machine. That state machine contains 3 steps. So first we're searching for an event that is called hail, okay, and then we name it hail, so it starts with hail. Then hail, we want to find out if within a time period of 1 hour after hail there's a tornado, okay, then we call that tornado. And the last piece in that state machine is supposed to be a thunderstorm. So we're searching for event types which are categorized as thunderstorm, and the start time has to be within 2 hours since the tornado. So now we're searching for that, and let's just do the result. So we get something like a funnel, And here we say, okay, it starts usually with hail, then of course tornado, and then thunderstorm wind. And you can also visualize that very easy in that environment using a funnel chart. And now you see 100% is of course hail, then tornado, and then thunderstorm wind. So there were a couple of occasions where first was hail, then tornado, then thunderstorm, just with classic KQL. And then I think there was also a question in the chat from which location we are broadcasting. So I took my public IP in this building that we're in, and then I'm using the function called geoinfo from IP address. We're getting the data to get the geographic, the latitude and the longitude and a bit more information. And when you execute it, you almost know where we are. So we are somewhere in the Netherlands, somewhere in Amsterdam, and yeah, it just works. You know, it's heavily used. You get the information from this IP address, like country, city, county, and of course the latitude and longitude. And if you're into drawing stuff, of course, you can also draw Kusto on a map. It's just some fun. So let me just zoom in a little bit, and then paint Kusto on a map. So that's just a bit of fun. So we define some polygons, and then we do random stuff in the polygon. So that's the stuff that you can do with Kusto here. Okay, more seriously, we also added the capability to execute, and let me just stop that here, to execute Python and directly where the data sits. So we have the capability in this example to do a range query, and then for the data that was generated, so for 363 steps, to evaluate Python. It's not something that you get through log analytics, but if you have like a classic Azure Data Explorer cluster or an event house, you can do that. So you start with Python, and then you have Python code, and Python code is being evaluated and returned back and rendered as a line chart in here. So customers are using that if they have like specific logic where they need to have a programming language which is not yet available in Kusto. It's also in heavily used. So rendering using Python directly where the data is. This is the most important. Thing. Okay, so now let's reset our mind a bit from KQL, and let's look at a couple of the enterprise features which we have built. I won't take too much time for that. So this is an Azure Data Explorer cluster. Those Azure Data Explorer clusters, when it's about security, most of the still like teams out there in the world and companies want to apply network security. So they would like to be able to disable the public access or allow access only from a couple of IP addresses. We have that. Then once the public access was disabled, they still would like to connect to the system. So we have a private endpoint capability. So from customer networks, they can reach via a private IP address to a cluster which is hosted in Azure. Managed private endpoints are important if Kusto needs to make outgoing requests to other services, like another Kusto cluster for cross-cluster queries or a storage account for ingestion. And restricted outbound access was mainly built to mitigate against the threat of data exfiltration. So here you can say, I only allow outgoing requests to a couple of FQDNs, and I'm in full control over those FQDNs. So that took us, it brought us quite far with enterprise customers. And yeah, let's see what we have here. Okay, improved documentation, Kusto Detective Agency. I'm going to talk about it later. Yeah, so that's what I wanted to show you on this timeline. Now, next, Event House, Fabric. Since 2023, November, Event House is generally available. So Event House is the Kusto offering packaged as a SaaS solution within Fabric. Fabric is the new SaaS offering of Microsoft. And within Fabric, there's something that's called real-time intelligence. And within real-time intelligence, you find the Event House. That's what you have seen most of the time me demoing now. It's a SaaS environment. It's not a PaaS environment. So we allow ourselves some opinion about how certain things are supposed to run. For example, You are not able to select the size of your engine cluster nodes. We are of the opinion that we know better and that we would like to reduce all of these friction. You get real-time dashboards, which are even better than the existing Azure Data Explorer dashboards. You get a Copilot integration. You will hear more about the Copilot stuff at the Ignite in a week or so. We support Data Lake, so data Parquet natively. You can query it efficiently. We support now graph features. You'll hear about that later. Also vector operations. And we became a Ring Zero service. A Ring Zero service, that's a specific Microsoft term. This means whenever we build out a new cloud in a new country or a sovereign cloud or something, we deploy in the different services in rings. So Ring 0 comes first, then Ring 1, 2, 3, 4. And we have now been made officially a Ring 0 service. So there are other services which are depending on us, and we need to be in that region first for other services to operate in the right way. And yeah, November 2024, we are here. It's KustoCon, and that's where this timeline ends. So let me show you a couple of these things again in a demo. Okay, so we were here. I already showed you the Kustainer stuff. Let's start with, yeah, why not? Let's start with Graph. You'll hear more about Graph later by other speakers. This is just like we've been internally funded to add graph technology to provide context to this data or provide context to time series data most of the time. And the real benefit of it is that you don't have to, in order to contextualize data, have a separate database on the side. They are like excellent choices, of course, but our goal was to get to use some of that magic of those graph databases and put them directly to where the data sits. Now all data sits in Kusto, so it makes a lot of sense to enrich the engine, to extend the engine with capabilities of graphs. And that's what we did. And the major thing that we implemented was this operator called graph match and also make graph, which allowed variable length edges. So if you look at this path definition, it consists, the path consists of nodes. Of course, everything in the parentheses is nodes. And then the edge is this one, and it can be a variable length edge. Something like that with joins would not have been possible because Kusto joins don't allow you to do recursive joins. So you would exactly need to know like what are the hops that you would need to take. And here you can say, okay, from 1 to 3, from 1 to 10, from 1 to 100. And the system is finding the right paths for you. You can also, of course, apply constraints here, and then you can translate it back to the tabular expressions. If you execute it, you get something back. Most of you are probably used to those kinds of strings, so just having strings, or let's say large logs in their database. You don't have to have a dedicated table for nodes and edges in your system. You can just create them during query time, as I do here. This is just a simple co-occurrence recommendation stuff. So a start IP is issuing a request to a resource, which is executed by another IP address, and that other IP address is doing a request to another resource. So, and it's giving you recommendations. There's also a lot of values in the security domain. This is an example of Bloodhound. Here we want to find out if a user can RDP into a computer, or a user is a member of a group that can RDP into a computer. And all of that is returned to you instantaneously. If you would like to model something like this with joins, it's possible, but the readability is definitely less. And let's have a look at something that's more like a social network analysis. In Kusto, we also have the data of our GitHub events, the public GitHub events, and here I did some research on my repository and with whom I was interacting with. So I gathered a couple of suspects. And if you use Kusto Explorer, you can just execute a statement like this, end it with make graph, and it's going to render you the result in a nice graph. You can even switch to a 3D version. And I know that for security guys, it's most important to have a dark mode. You can browse the graph, you can turn it around. We also have some time series, some timeline visualization. So all of these things are built into our product, and we believe that Graph will have a major impact on our product going forward. Okay, so what else do we have? I think we have something on the Fabric side, okay? So let's do the following, okay? So we do a Fabric end-to-end demonstration, and we start doing that by going to my workspace, which is this. And we start with creating an event house. So we start from scratch, creating an event house. We click on it, we give it a name. Let's call it KustoCon. Now what's happening when I click on it, it's creating a new Kusto environment for me. I don't have to go to Azure and wait for, 10 minutes until the cluster is started. It's almost instantaneously available for me. Okay. Now I have my new Kusto cluster. It gives me some information. I don't need it at the moment. Now let's add a dedicated database. Let's say, let's do BikeDB. It's a completely new database. Maybe there's also a typo in there, but it doesn't matter. Now once I'm done, I have my new database, and then I'm actually ready to ingest data into that database, which is happening in a second from now. And now I have my database environment. I can take a look at the system overview, but there's not that much that is happening here. You can immediately click on Get Data. I say, okay, I want to get some real data from an event stream. Okay, I don't want to use an existing event stream. This was a bit of a mistake. Let's cancel it. Let's get data from a new event stream. And data ingest. I create it. Now on that event stream, which is right now being created for me, I'm going to select some sample data set. Wait a second, it should be available soon. If the demo gods are with me. It should be actually going like way faster, but okay, let's see. I think we still have some time. If not, I can skip that one as well. I have faith, okay? Okay. Five, four, three, two, one. Almost. Come on. I blame the network. It's okay. Okay, let's wait for 5 more seconds. If not, then I'm going to stop it. Okay, so demo gods are not with me, but what I would have shown to you is that that you could create this demo environment within a really short period of time, just connected. And what you would have seen is a database that would have been populated immediately with data. Of course, I already prepared something, okay? So what you would have seen here is something like this. So we would have created something like that. So a full-blown dashboard, which looks almost like my private home automation, including anomaly detection, filters that you can do on specific days. You would have been able to look at the data for longer periods, to zoom in for certain things. All of that is available actually super fast with Fabric. You could also do forecasting here. So that's what you would have been seeing if it would have worked. Okay, never mind. So now we've seen a few things around real-time dashboards, SaaS, co-pilots as well. Delta Lake support is something that you will see if you're using external tables. All of that is available in Fabric. Now, Fabric is a universe on its own. So if you're planning like new developments around Kusto or data platform in general, then you should definitely have a look at it. A lot of energy of Microsoft is going into Fabric, into Microsoft Fabric. It does not only have like real-time intelligence, it also counts with Power BI, data science, data warehousing. Everything is based on unified cost model, unified storage, and AI is infused in all of these parts. Okay, Kusto Detective Agency. Actually, my primary job being Professor Smoke in the Kusto Detective Agency. Let's just give you some indication of like how big it actually is. So far, there were almost 20,000 players, right? 10% finished season 1 and 14% finished season 2. So it's challenging, but it's also a lot of fun. Like customers went there, for example, on a Friday afternoon, had a beer together, and were solving cases. Now we're planning on the next version of the Kusto Detective Agency. Okay, it's going to be a team competition over a weekend, sometimes early next year. The fastest team will win, and if you have some feedback to share, please go to that link that I have over here and share your feedback. It will be heard. And you know, I just want to announce it. There's also a prize. So for the fastest team who is going to solve the competition of in Kusto Detective Agency, will get $10,000. Okay, let that sink in. So far, the gifts that we gave away were a little bit smaller. But if you're solving it over the weekend and you are the first who are solving it, then you get $10,000. Okay? So please go to aka.ms/Kusto/KDA, the Kusto Detective Agency /next. Provide feedback on what you want to see, what you like, what you don't like, and keep your ears and eyes open for Kusto Detective Agency, the next episode of it. And it's going to be fun for all of us. A couple of roadmap items which I want to mention. So today, actually, I want to use the opportunity of this beautiful conference to make an announcement, right? So we are continuously heavily investing in Graph, and today I would like to announce it's generally available 2 new features, which is the star pattern and being able to provide default node IDs. And we're releasing 2 new operators, which were asked for since quite some time as public preview. This is the graph shortest path. So to find the shortest path in a graph between 2 nodes and graph mark components, this is very useful for doing community detection. In general, our investment areas in Microsoft is, as I said before, Fabric, Fabric, and Fabric. And our customers enjoying it. Please pay attention to Ignite, which is going to come up in a week or so. And there's a lot of cool stuff which we are going to announce publicly, and have fun at Ignite, watching Ignite. Some call to action. If you would like to be part of the next FabCon, so the next big Fabric conference, and you would like to talk about all things Kusto or whatever you like to present, please register at the Sessionize, submit sessions. It's very important to have our community be represented at FabCon. It's at the end of the day a community-driven conference. It's never too late to start also with the old seasons. It's great fun experience to learn about Kusto Detective Agency. Start with the Learn It All approach and learn and invest into real-time intelligence. We have an entire track, multiple learning episodes here. If you would like to try out our technology, you don't need to spend money at all. You can just use the free cluster, same way as I did. Or you can join a Fabric trial. You get like 60 days of Fabric usage, and you can use Kusto if you like, or all of the other beautiful services that we are offering. And with that, I'm not sure if there are questions. If there are questions, I can also answer them after that offline while the others are speaking. And yeah. So self-hosted Azure Data Explorer clusters, so self-hosted data, what does that mean? So self-hosted is a big term. So self-hosted for, I would say 99.9% of the scenarios means that you deploy your own Azure Data Explorer cluster and you are using that service. So that is something that is self-hosted. And customers are doing that a lot. Yeah, we have tens of thousands of customers who deploy their own Azure Data Explorer cluster or their own event house. And they're doing that for various reasons. So we have customers from the automotive industry, a lot of friends. We have customers from mining, energy, oil, security customers. So there's an entire spectrum of all kinds of customers out there. Yeah.
One last question.
Mm-hmm.
Kusto in a container, is that just for practice or could this also be used for local simple workloads? The reason for IT workloads we now rely on InfluxDB or time series DB on the hash would be great. Kusto container will be kind of opportunity.
That's an evil question. So I repeat the question. So the question is, those containers that we have seen, are they a good alternative for open source databases on the edge? On the edge means where the data is being produced. So let's say you are in a manufacturing environment, you have a production plant, you collect data locally, and you would like to protect yourself against an outage, for example, a network outage. And of course, the factory needs to continue to produce goods even if the network connection is not available. So it makes a lot of sense to have a database on the edge. And they're really good ones, like InfluxDB or TimescaleDB, or some also use SQL sometimes. What my recommendation would be is investigate and see if Kustainer would be a fit for you. In general terms, we don't allow production use because we can't support it. But you can play with it at your own risk, of course. But there are also other solutions like ClickHouse, which provide a subset of the KQL language, and it can be deployed on-premise, which would be another option, for example. Yeah. Okay. Okay, so with that, I would like to say a big thank you. Thanks for having me. Also, thank you again to all of our sponsors. Thank you. And it was nice being able to talk here. Cheers, guys. Bye.